Alright, today we will be doing a cross-country navlog. This is just to show that you know how to plan to another airport in the area you're in, taking in some considerations like altitude, wind, any other airports or airspaces along the way. So we're going to do a simple navlog, just that's not too far, just to get started. And this is using a paper navlog and also Foreflight. Let's just take a look at our navlog paper. So up here we have any notes. I like to use my climb out information here. And then over here I'll write the ATIS once I'm in the plane because I'll have this paper on me. Here we will choose our waypoints and our starting airport and our ending airport or our destination. Here we can write any other information, any VORs we can use. This will be our final course route. Here will be our altitude. And here is the wind at each point that we cross. So we'll have the direction, the velocity or how fast it is in knots, and then the temperature. We have calibrated airspeed, and then our true airspeed, true course, true heading, and then magnetic course. And then we also have our compass heading here. Over here we will have the distance of each leg and then our final distance, our ground speed, and then we will put our estimated time of how long that leg is here. And then you can also fill out the ETA as well, but I usually don't do that. And then here we have fuel, which is really important. You need to know how much fuel you're using for each leg. So each leg you'll fill out how many gallons. Over here we have information about the departure airport. We have all the frequencies and then as well as the destination airport. Let's get started. We're going to depart from Kilo Foxtrot Papa Romeo or Fort Pierce. So I'm gonna write that as my first point. KFPR, and we're going to do a navlog, let's do Foxtrot 45 since we have some airspaces and it's not too far, so that I can show you how to properly plan that. So what I like to do is go up here, I type in KFPR, and then Foxtrot 45. And what it will do is it will draw a direct line to that airport. However, we can't always do that because look, we're going through an airspace here. We're going through Stewart's airspace, and we also need to take in consideration of clouds, wind, and also we will be using visual waypoints. The first 2 points I like to choose are my top of climb and my top of descent. So how do we choose where our top of climb is? Well, first we need to figure out how high up we are going. This is up to the pilot's discretion. You'll mainly keep in consideration a few things. One, how far is your destination? Is it really far that you need to get higher up, or is it not that far? You don't need to go up to like 10,500. In this case, we're only going 40 miles. So I would say no higher than 4,500 just because it's pretty close. But we are going to look at other things like weather. So we want to see what the winds are, what gives us the best wind, a tailwind, or if there's any clouds that are too high. So how we look at that is we can look at our destination airport. We can look at the TAF. I'm going to say we're departing tomorrow at 8 a.m. So around 8 a.m. we might have a few clouds at 5,000, scattered at 3,000. That's not until noon, so I think it will be a pretty clear day. But like I said, we'll need to look at the winds. We just click winds, and these are the winds aloft, or the winds up high. So we're going to scroll for the time. So the closest time to 8 a.m., I'm going to use 6:30 a.m. And then I'm going to look at the different altitudes. Now these are actually really low winds, so that's good for my route. At 3,000, it's 300 at 2 knots, 6,000, 279 at 3 knots. So really either of those. I'm going to choose somewhere in between there. Something else to consider is if you're going west, otherwise 180 degrees heading to 359, you need to have an even 1,000 plus 500, so 4,500, 6,500. And if you're going from 0 degrees to 179, that number needs to be odd. So 3,500, 5,500, and then you add that 500. That 500 is for VFR traffic that we're adding. So since we're pretty much going east, we will choose an odd number. So I'm going to choose 3,500. So now that we've chosen our altitude, I'm going to write that in my notes. We're climbing to 3,500. Now, how long will it take us to get there? We're not going to guess. We're actually going to go look in our POH. So the POH for your aircraft will have climb information. Here we go, time, fuel, and distance to climb. So we're going to choose the number closest to ours. We're doing 3,500, so we will have to interpolate between 3,000 and 4,000. So we're looking at 3 things here. We're looking at the time, the gallons used, and the distance in nautical miles. So again, 3,500, we're interpolating. It's going to take 4 to 6 minutes, so 5 minutes, and I'm writing that up here. 5 minutes. It's going to take between 1.2 and 1.5 gallons, so 1.35 gallons. Next, the distance, so 6 and 8, so 7 nautical miles. However, if we look here, there are some notes at the bottom. So, first thing, we need to add 1.4 gallons of fuel for engine start, taxi, and takeoff. So yeah, we use up more fuel on the ground and our run up, so we need to add that in here. So under here, I just add plus 1.4 gallons. And then also, just keep in mind that mixture will be leaned above 3,000. So these numbers are true if we do that. Now this one's important. Increase time, fuel, and distance by 10% for each 10 degrees Celsius above standard temperature. Standard temperature is 15 Celsius. So let's see what the temperature is for this day. So we are going to increase by 10% since we're going to get about 25 Celsius at this time. So times 10%. So we'll get 5.5 minutes. And you can just use your calculator to do this, unless you know how to do that in your head. And then remember, I'm adding this first and then I'm gonna do that. So 2.75 gallons and then times 10%. And 2.75 times 10%, I'm rounding this up, that's about 3 gallons. And then 7 nautical miles will be 7.7. We know that our top of climb will be this, 7.7 nautical miles away. It's gonna take 3 gallons and also it's 5.5 minutes away. On your cross-country flight, you will need to be within 5 minutes of that. It's really hard to be off unless you completely fly in the wrong direction. But if you have all of that calculated correctly, like I will show you, you shouldn't have to worry. So the best way to do this, using Foreflight, we're gonna zoom in, and we know we wanna go in this direction. However, we don't have to go along this straight line because we're gonna be worrying about these airspaces. So what I like to do is we're using pilotage or navigating using looking around outside and using visual waypoints. Things like highways, bends and highways, intersections, the edge of a town, things we can see up high that we know, hey, once I'm passing this, that's my waypoint. So I like to change this to aerial map, and it's a lot easier to choose points. So if you have two fingers on here and you do this, this will pop up. It will tell you all kinds of things. It will tell you the direction, the nautical miles, how big it is, how long it is, how much fuel. It's a really good tool, especially for cross-country planning. So we're gonna head from KFPR, and we want to do it about 5.5 minutes or 7 points. I'm gonna use 7.7 nautical miles on here. And I'm gonna find a point that is about that. And look at that, the bend in this road right here is that. Now, we can also head south more. We could use this bend. It's up to you how you want to do this. I like this point. I don't want to get too close to all this congested area. And I know I'm familiar with this area. So 7.7, I'm going to put it right here, and I'm just taking this and I can drag it around, and I'm going to move it here and drop it. And then I can adjust it if needed. So I'm going to put it right here. And now that is my first waypoint. I like to make it a little off of the point because when we are flying in the left seat, we look out to the left on our left window and we want to see that point. So if we're flying, I should see this bend on my left side. So I could put it like right here, okay? When you click on the leg, it will actually tell you information about it. It will tell you your heading in magnetic, and this is like, it rounds it up or down. So it's saying it's 7 miles, but remember we calculated it. It's 7.7. Now we're going to write all of this in here. So altitude, your altitude will be the same for everything. So we have 3,500. There's no VORs around this area, so I don't need to put that in. This is our final number once we get all the wind correction. I'd like to finish the rest of my points before filling this out. So I'm gonna go ahead and do that. The next thing I do, I kind of go backwards as I find out my top of descent. The way I do that is I figure out my altitude I'm flying, so 3,500, and this is important if you're not flying in Florida or somewhere along the coast. You want to subtract the field elevation of your destination airport. Here, we're landing at like 20 feet AGL, so it's not much, but if you were flying like somewhere like Tennessee, you may have to subtract like 200 or something from that, whatever the field elevation is. I use the rule of thirds, so I divide by 300, so I take 3,500 divided by 300, and that is how many miles away I need to descend. So I got 11.5. So again, I'm going here and I'm going to choose 11.5 away. However, look at this. I have 2 airspaces I need to worry about. So I need to choose somewhere that is away from those. So 11.5, there's the bend in I-95. I'm going to use that for my top of descent. Again, I can move it right here so I can see it outside of my window. Now, in between, you can choose as many points as you like. However, the main rule is you need to be able to see it from 20 miles away. So I'd say from 10 miles to 20 miles, you need to have a waypoint, because over 20 miles, it's hard to see. From your point you're currently at, you have to be able to see your next point. So it's wise to stay around 15 miles. So this one, if I click, It's 25 miles, so I need to have a point somewhere in here, preferably in the middle. I'm gonna find one farther out, away from this Stewart airspace. This bend is looking really good, and it's on the edge of a neighborhood. So right here. Now I'm double checking. This one's 15 miles. This one's 11 miles. They're both less than 20. That is fantastic. So these are the points for my Navlog. Next, I'm just gonna turn it back on VFR sectional to make sure I'm not in any airspaces. We are good. All right, now I'm going to name all of my waypoints. I'm writing top of climb. Just make note that you know where it is, which point. And I'm gonna give it a name. So this is Okeechobee Road. I'm gonna call it the Bend and Okeechobee Road. You can name your points however you like, as long as when you're in the air and you're reading this, you know what it is. Now, other things we need to write about this point. We need to know how long it is and the heading. So it is 7.7 miles. So I'm going to put 7.7. Again, this one isn't really accurate. It like rounds really weird. The course is 225 magnetic. However, true course, we need to know true heading, not magnetic. So what we need to do is figure out what the true course is. We have our magnetic course, but we need to know true. Well, we have magnetic variation. So if you zoom out, you will see these isogonic lines. Let me turn on the VFR sectional. There's these maroon dashed lines, and they tell you what the magnetic deviation is. So you're going to find the one closest to where you are. So here's the one closest. It is 7 west. How we find this, I like to turn this over. You don't have to write this on every side, like every time you do an Navlog, but I like to remind myself every now and then. How we figure out what all of this is and what it means, I'm gonna write you a formula. So true course plus or minus your variation. So that variation we have here, that will give you your magnetic course. Look, that's already what we have, right? But we need to find our true course. Do you remember in algebra in 5th or 6th grade where you do x plus y equals z? And you have to subtract to get on the other side? Well, that's what we're doing here. So just remember this west is best. So anytime you have west, you're going to add here. So normally we would add because we have 7 west, right? However, it's opposite because this is the number we have. We have 225 and our variation is plus 7 because west is best. That's just how it is. If it's east, you'd be subtracting. Now, this is what we're trying to get, our true course, because that's what we're trying to get on our Navlog. So you're gonna have to actually subtract 7 from this number to get your true course, okay? So 225 minus 7, we will get 218. All you gotta do is, if you have a west number, just subtract that from here and you'll get your true course if you're using Foreflight. All right, so our true course is 218. So I'm writing that in here. I'm naming my points. This next point will be called Bend in I-95. And this leg is 11 miles. And again, I'm subtracting 7 from this number to get my true course. So we will get 167. Okay, I'm gonna finish the rest up here. I've just completed the rest of my points. My destination is this last point. I filled in the altitude. It will stay the same throughout the whole flight. I filled in the true course by subtracting my magnetic variation from my magnetic heading, and I've put in the distance of each of these legs. To continue, we are going to need some more information. We need to figure out what the true heading, but the difference between true course and true heading is the wind. The wind can affect the way you fly. If you've noticed while you're flying sometimes, if you fly straight and there's wind, you'll actually end up going to the side. So we're actually going to correct that ahead of time, and we're going to change this heading based on the predicted winds to make us fly directly to that point. Because think, if we're right here and we're trying to get here, we're actually going this route, but the wind's pushing us this way, we're actually going to end up right here, like over to the side. And what if we're near an airspace? We don't want to do that. So we're going to look at the winds aloft and change this, and I'm going to show you how we can change it. We're going to look at winds aloft for each of these points. So you can just choose the airport closest by. And again, we're going to weather, winds, and scroll to the time of your flight. Again, you can only do this within like a day of. I'm choosing 6:30. I'm going to do 3,000 because that is the closest to my altitude. And I'm writing 300 at 2 knots right here. So direction is 300 at 2 knots. And the temperature is 18 Celsius. Now that's actually not a lot of wind, so we're not going to have a big wind correction number here, if any. And then I'm doing the same for every other leg. I just go to the closest airport. So these 2 points, I'm going to use Stewart. It will probably be similar. Yes, same number. A lot of time they are. My last one, I'll get the winds aloft for the destination airport. It's a little different. 270 at 3 knots. For our airspeed, we're going to go in our POH and look at what the calibrated airspeed will be and the true airspeed. We had our time distance to climb. Now we're going to look at cruise, which is usually the next page in your POH. Again, you may have to interpolate. I'll use the number closest to 4,000. I'm going to be using an RPM setting of 2,400, and these are all based on temperature. So we're closest to standard because it's a big jump to 20 above and 20 below. I'm going to stick to standard. You can interpolate if you need to, but we're pretty close to standard at this time. So here will be our true airspeed column. So it changes based on your pressure altitude. So again, this is pressure altitude, so take in consideration of where you're flying. I'm going to be using this. So 4,000 at 2,400 with standard temperature will be at 109 knots. However, look at the bottom. Cruise speeds are shown for an airplane equipped with speed fairings. My plane doesn't have those, so I have to subtract by 2 knots. So 109, it's actually going to be 107. So I'm going to write 107 for our cruise here. To find our calibrated airspeed, this little area up here, our indicated will be about 74, so it's about 74. I strongly suggest, if you are continuing flight training past private, to invest in one of these calculators. I got this one from Sporty. If not, there's a website that you can use. I'll link below. There's a website you can just use for using this. However, you cannot use that website on your FAA written test. You can use this on your FAA written test. I'm not going to go over what this calculator can do at this moment because there's a lot on here. I'm going to show you how to use it for this Navlog. So we're going to press Flight, FLT, and it has all these options, right? So first thing we're going to do is find our wind correction. So there's a button that says wind correction, not wind component. We're doing wind correction here. Click that. It's gonna ask us all these things and we're gonna fill it out and it'll tell us the rest. So, do we know our ground speed yet? No. So we're gonna leave that empty. I'm gonna clear what's in there. True airspeed, we know we'll be going 74. So I could put that in. Our true course, yes, that will be 218. True heading, that's what we're trying to get, so we don't know. Wind speed, it will be 2 knots. Wind direction, 300. And voila, it tells us everything else. So we're gonna fill this in. Ground speed will be 73.7. We can round that up to 74. Again, like I said, since we have low winds today, it's not gonna be that much of a change. Our wind correction angle will be 2 degrees. So because of these winds, we will be correcting by 2 degrees. So we're adding +2 to that. So our true heading, we can just do that in our head, right? Like 218 + 2 is 220. It also will tell you right here, true heading is 220. I'm gonna show you what would happen if we had a high wind day. So let's say, yes, it's coming from 300, but what if the speed was 18 knots? If it was 18 knots, we'd have to change by 14 degrees and our ground speed would significantly, not significantly, but it would change. So that's just an example of how the winds would change your flight. I'm gonna do the rest for all of these. Remember earlier how we had to subtract our magnetic course? Well, now we need to add that back for our magnetic heading. It seems silly to add 7 again because we already subtracted it. However, winds are in true airspeed. So we had to change them into true course because of the winds being in true. So now we're putting it back into magnetic. So we're adding 7. So 227. All right. Now, compass heading. This, we're not filling this out because I fly G1000 and this is for magnetic deviation. Under your compass, there'll be a compass card and it will have the information for that compass deviation. I need to calculate that for my aircraft, but some planes require that, so you just have to check your aircraft. So this is the final heading we'll be flying in the plane. I'm gonna circle it, and you can also write it over here. So this is our final number we're flying. So 227, 175, 155, and 185. So what that means, after takeoff, we are going to turn our plane to the 227 heading. We're gonna bug that and fly that. Now, for how long do we fly it? That's what we're gonna find out next. We're gonna find out how long each of these legs are and how much fuel they take, and then we'll be done, right? Back to our calculator flight. We're gonna go up and we're gonna click ground speed, okay? Here, it will give us distance, duration, and ground speed. We have these two, we just don't know the duration of each leg. So we're gonna put in our ground speed and distance to get our time. So the distance, it's in nautical miles. That's why we filled this out, right? So it's gonna be right here. So we have 7.7, and we got that from up here, right? Our ground speed will be 74. So this leg lasts 6.24 minutes. 6.24. And I'm gonna fill out the rest. I'll do one more with you. This distance is 11, so I'm writing 11. The ground speed here, 108, because remember we're at cruise here, we're going faster than VY. Oh, 611. Now, all we need to do to complete our Navlog is figure out how much fuel each leg is, and that's important. Why? We need to know if we have an emergency along a flight, how much fuel we have used or if we have left. It's also good for flight planning. It gets you an exact number. So right here, we're going to go to flight, up onto fuel. Where we got our airspeed earlier, it's also going to tell us how many gallons per hour we are using. So we're wanting to know how many gallons per hour we are using and then compare that with the time, and then we will get our fuel. So this first one, remember, we have our separate number because we're using some for taxi as well. So it's exactly 3 gallons. So that one's already done for us. So 3 gallons. Down here, we're gonna figure out how many gallons per hour we'll be at cruise. So again, I was using 4,000 at 2,400 RPM. At standard temperature, we will have 8.5 gallons per hour. Okay. So on our calculator, where it says rate, this is where we're putting gallons per hour. 8.5 for this flight today. All right, now all we need to do is put in the duration. The duration of this leg is 6.11. And there we go. That is how much fuel this leg uses. 0.87. I'm going to round up. You don't have to. I like to for safety. I'd rather think I'm using more fuel than I am. All right. I'm going to fill in the rest here, and we are done. Here's just a few other things to help you be successful. In this column over here to the left, we do have the VORs. If you're close to a VOR, you can actually enter in some information here. So actually, I am a little close to the Palm Beach VOR. So I can go ahead and click that. Make sure you don't click the airport. And once you click on that, you can get the frequency, and I'm just writing the frequency in, and that's what I'll put in my nav in my G1000. And I'll just do that before I take off, like to have it already. And then I can use that tool that I used earlier to plot my points to see how far I am from that VOR, and it will also tell me what radial I'm on. Next, don't forget to write all your frequencies in of the airport you're departing from. You could put in the ATIS and the ground and all that, and then your destination, you would just click on it and write down whatever you need. There's also an area to write the field elevation, so you remember to put in your minimums properly. And then at the top, I usually write down the ATIS information or NW craft, just so that I'm able to remember that real quick. And also don't forget to tally everything when you're done, especially if you have a check ride or stage check. They want to see that you've done that all. So make sure you add up all the nautical miles, time, and the fuel. And the last thing I want to show you is how to save this route. So if you click the share button and then click flights, it will actually save to your Foreflight account, and you can access it on different devices. That way, if you accidentally delete the route or something, it will be saved